understanding COVID-19 vaccine, what you need to know. So the talk will be given by Reverend Dr. Swee, who is actually a medical doctor by training. And I will be your moderator, Robin. I'm a microbiologist and a biotechnologist by training.
Welcome all of you. This talk will be recorded and then it will be made available if there's a need to. Once again, for joining this talk, I put together whole area of understanding the vaccine, actually more the infection and the vaccine, so that each of us have better knowledge to decide. Okay, I think there's something that's very, very important for us in this time and season. Although I'm a medical doctor by profession, by training, okay, I'm still a pastor for SSMC. I've tried to read through a lot of the literature that's come out about COVID infection and vaccine, and try to bring down to a level that hopefully you can understand and comprehend, so that you are better equipped, okay, to be able to make a decision. I think that's important for us. For those who have answered my Google form, 88 respondents came in by 4 p.m. yesterday. Okay, after you came in within the, okay, about 50% of you says no problem, you have really take the vaccine. Okay, 41% is not sure, 9% says no. So these are the figures of what we have. Half are okay, 41% not sure, and 9 already says no. Okay, but I hope that after the talk, there can be a rethinking of your decision. Of the questions about the COVID vaccine that you all answered the Google form, okay, these are the major ones. A lot of you are worried about the side effects from the vaccine, as well as the long-term effects from the vaccine that seems to be the highest in terms of percentage. Effectiveness is something that also bothers some of you, and obviously any harm to you. Also the fact that the vaccine is being developed too fast within 9 months. Does it mean that they have taken a shortcut somewhere? Or effect on your DNA, will it change you? Kind of things. The others are of less concern to many of you. So these are the questions that I asked in my Google form and give us a rough idea. And most of this I will answer as part of my talk. So the whole area of understanding COVID-19, the infection and vaccine. Now, first of all, we need to understand the virus, the COVID virus, to better understand the whole condition. Okay, as you are very well aware now, okay, on the right hand side is the COVID virus, a diagram of it. Okay, it's covered by a capsule with all these spikes, and within the capsule is the RNA, okay, the genome for the COVID-19 virus, okay, genome. So this is the diagrammatic representation. On the left hand side are actual electron microscopy pictures. Okay, that's why I call it coronavirus. A crown, they got a crown around it. Okay, so that is how it looks like on electron microscopy, 60,000 times, or scanning microscope, the orangey things that you see is the actual coronavirus. So there's actual coronavirus that you're seeing, and that's what it looks like under electron microscope. So now this with electron microscope, you put a virus under the microscope. That's why straight away they can say it's a coronavirus, because the appearance is very, very classical. So this is the enemy that we are talking about, as it were. Sometimes it's good to have a picture of the enemy. Let me explain to you how the COVID-19 virus in the way enters our body. Important. This is just a diagrammatic representation of the virus. Okay, inside the virus is a viral RNA, and outside the red things are what called the spike proteins. Okay, this is just a diagram. The actual spike proteins are 3D model. Okay, but this is just a diagram of it. So inside the virus, the viral RNA, when it comes to contact with the mucosal surface, especially in your nose, your lungs, and all that, the spike protein is the key that attaches to ACE2 receptor, angiotensin receptor, and this is the key and the lock. If the key is there and the lock and key is there, then the virus is taken into the cell. That's how the virus enters the cell. And once it enters your cell, it will open up and release its own RNA, release the own RNA. And once it's within the cytoplasm of the cell, what happens is a part called the ribosome, don't worry about the names, ribosome will start reading the viral RNA and produce viral protein according to the viral RNA. And all this production will just go on automatically in your cytoplasm. Once the virus enters and the RNA is released, all these are automatic, it goes and be produced. I think that's something we need to know. And once they are produced, they will come back again and join back again and come back into form the virus itself again with a capsule and with a spike protein. And once that is developed inside the cell, they either can get extruded from the cell, or if there's a lot of viral particle, the cell can burst. The cell literally can burst, and that sets the viral particle free. So it's important for us to understand that this is the whole process, that the key in the whole area is the lock and key, the spike protein and the receptor. That's very found easily in your nose and in your lung tissues and all that. Okay, that's where the whole entry point comes in for us to understand. And once it enters the cell, the whole process is automatic, and the new viruses are formed and they are released into your system to infect other cells and to multiply further. Okay, and this multiplication can take place very, very fast. That's important for us to know. Now, this is the transmission. So we know that the points of entry is the eye, because it's very there's no thick layer of skin there. The nose, especially upper part, and your mouth. Once it goes in, all this is right for the virus to attack. So if infected person cough out or breathe out the virus, if you are too near, you inhale in or whatever, okay, it can enter your system and get infected. Okay, so the main mode of transmission, aerosol, airborne, droplet. Okay, that's the main mode. Contact surfaces, there's a lot of studies, may be important in some, but may not be important in others, depending. So far, I can find the virus in other parts, your urine and feces, but don't think that's an important aspect of transmission. So we mainly talk about aerosol, airborne, droplet infection. And this is the main mode for transmission from one who's suffering from the virus to one who's susceptible. I think this is important for us to know. Now, the main presentation for COVID infection per se, okay, these are the figures we have generally. The whole fever is a prominent one, loss of sense of smell, and dry cough. So you need to have major one to look for is fever, loss of sense of smell, and a dry cough. Mucus production here or there, shortness of breath will be a not very common one. Fatigue, also can get sore throat, muscle pain, joint pains. Okay, these are the other one. But the major one is fever, loss of smell, and a dry cough. Okay, non-productive cough we call it. So these are the figures that we have thus far. Okay, so that's important for us to know. Now, this only holds for what I call symptomatic cases. If you are asymptomatic, which means that you don't have fever, you got no cough, you got no loss of scent, you got no tiredness and all that, okay? So this is only for symptomatic cases. So you can have the virus inside you producing, and yet you are not reacting to it, so you don't show any symptoms. And this in some ways are also very dangerous, because you are having the infection and not knowing it in the way you can transmit it. Okay, so keep this in mind. Fever and cough, dry cough and loss of smell is a good guide, but it does not distinguish between one and the other. I think there's something for us to keep in mind as well. Now, this table just tries to show us that COVID-19, there's a lot of overlap with the common cold and the flu or allergic reaction. But again, fever, dry cough, loss of smell are more prominent, okay, in COVID-19 infection, as opposed to the common cold and the flu. The flu, you don't get loss of smell unless it's very, very bad, stuck up nose and all that lah. Okay, so these are the general figures, but there's not one thing that can tell you whether you're having the COVID-19, common cold or flu. There's no one thing except to do a test. And I think that's important for us to know as well. Now, I show this diagram just to remind us that 2002, we had the SARS epidemic. The death rate at that time was 9.6%, which means it's very, very high. Now, 2012, we had the Middle East Respiratory Syndrome. The death rate was higher, 1/3, 34.4%. And yet, both of these, compared to COVID-19, COVID-19 death rate on the average is 4%. And yet, these all was controlled very easily, okay? MERS only got about 2,500 cases. SARS got about 8,000 cases. And yet, COVID is still rising and rising. You may understand why. Why, in a way, is COVID so more dangerous and cause more death than even the MERS and SARS? The reason for this is in this graph. This is the COVID-19 disease timeline. When you're exposed to it, you catch the virus, and the virus enters you and start multiplying. It reaches a peak and then it goes down. Now, this red line here represents when you are infectious. This green line here represents when you are symptomatic, means you got fever or got cough. And remember, a lot of people got no fever and no cough. Okay, think about 50% may not have any fever or cough. The key part is this portion here that I put as red. What this means is you are infectious before you have symptoms. You are infectious before your symptoms, possibly about 3 even to 5 days. We are not exactly sure how long this period is, which means that before you get symptoms, if you do get, and 50% don't get symptoms, before you get the symptoms, you're already infectious and you're spreading the virus. So this explains why COVID-19 is more dangerous than SARS. In SARS case, it's only when you are having symptoms, when fever comes, then you are infectious. That's what happened in SARS. That's why the temperature checking played a big part in controlling it. But COVID-19 is different. COVID-19 is infectious before you have the fever. Okay, that's why you start spreading before you know you are sick and you think you are well. Okay, so that's why COVID-19 is more dangerous and has spread much more and caused more death than SARS. That's more deadly as an infection. And all of them are coronavirus. Now, this chart is our Malaysian figures. A study was done by our own Sungai Buloh Hospital on 6,000 old patients. Okay, this says 50% of them no symptoms. Means you can have the infection without any symptoms. 40% mild to moderate. Mild to moderate, a bit of fever, tiredness, maybe a bit of cough, but nothing much to recover. Only 6% go on to severe disease, or actually about 10% go on severe disease, 6% severe but you recover, 3.7% goes to ICU, and about 1.3% death was the inline. Okay, so these are figures from our own Malaysian studies that's published online. Okay, so but how do you see this figure? Remember this figure, 50% have no symptoms, which means you have the infection, you are spreading the virus without knowing it. And this is the danger that you need to keep in mind. Okay, now this graph is to show you Malaysian figures again. Okay, from last year May until now, and they're going into January. Okay, the figures are going up. So figures are going up. Okay, our mortality rate is about 14.4 per million, not too bad compared to the world. Our infection fatality rate is only 0.4%, which actually is very, very good. But this figure is deceiving. Everybody say, oh, I got 0.4%. Don't worry, I get infection, I'll get well. This is only the overall fatality rate. Okay, a lot depends on all your other conditions. What are the other conditions that will increase in the way your death rate? Okay, one is the age. The older you are, the more likely you are to die. Go even up to 15%, you're more than 80. 70 to 79, you're about 10%, 9% odd. Okay, so don't have the idea that it's got 0.4%. Young people say don't bother. Okay, so mild, I'll just get it and recover. Some young people do die. We don't know why. Okay, so don't have the idea that it's just a mild flu. I'll think of the effect that you have the infection, and you pass on to your parents, your grandparents, your old neighbors that they have. You may not die, but they can die. I think that's important for us to understand, okay? And also what called comorbidity, means other condition that you have, okay? And then you catch the COVID virus, heart disease, diabetes, lung disease, hypertension, cancer, okay? All this will increase your risk of dying from COVID. That's important for us to know, okay? And even if you are male, your chances of dying is higher than a female in all the studies. Male has a higher mortality rate than females. There's explanation for this if you're interested, okay? So I think don't always look at the figure of 0.4%, don't bother, okay? You got to think of, because you are not protected, you have the infection, you may recover, but somebody close to you in your family may catch the infection from you and die from it, okay? Especially the older people in our midst. That is a point that we need to be very careful about. So the whole list of what called comorbidities, if you are older, 65 or 60, depending which study you see, high blood pressure, diabetes, chronic kidney disease, heart disease, chronic obstructive airway disease, lung disease. If you are fat, your basal BMI is more than 30. If you are immunosuppressive drugs for autoimmune disease, for cancer treatment, for all this, okay, there's also a risk factor. If you are smoking got lung damage, higher risk. If you are pregnant and get COVID, mortality goes up. Okay, all these are the known comorbidities. They talk about cancer, Down syndrome, sickle cell disease, other possible risk factors, asthma, and all the rest. So there are all these comorbidities that increase your risk of dying from COVID. Although we talk about 0.4% country, our whole country fertility rate, but that's a very misleading figure. Very misleading figure. Keep that in mind, okay? So as of yesterday, okay, worldwide, we have 113 million cases. This is the worldwide figure. And 2.5 million people have died from COVID-19 infection. These are the cases that we know. Even the cases, there's 113 million. It's not all the cases, I'm sure, because a lot of people are asymptomatic. Asymptomatic, they don't know, they don't test. So the figure is grossly underestimated to me, okay? Death also may be underestimated because some people die, they think it's old age, they never test, actually it's COVID. Okay, so, but these are the figures that we have, and these are very, very high figures. Very, very high figures. As you have heard, America, more than 500,000 have died. And there's more Americans died from COVID than World War I, World War II, Vietnam War combined. That's how bad is it, even for America, okay? And yet, first thing I want to note, there are people who claim COVID-19 is a hoax. It's not a real infection. There's no such thing. It's just a flu, that's all, okay? These figures do not lie. There are cases, we have proven it. There are deaths that has happened. So don't go and be taken up with some of these stories you read, you hear in the internet, as well as receive all the video. No such thing as COVID. It's just a lie by Big Pharma to make money. Let me assure you, it is not a fairy tale. It's not a hoax. It's a real life infection that is killing a lot of people. I think that's one fact that we need to do. And we do know that even if you recover from COVID, we now know there's a condition called long COVID. What is long COVID? Long COVID is even after you recover and you think you are well, there is a high percentage of people who continue weakness, pain, cannot sleep, anxious, cannot walk too far, their heart and all that affects all the organs of the body. These are the residual damage from the COVID infection that we are now seeing. So long COVID, because Wuhan has the highest, started the earliest, more and more cases are coming up, that those after COVID infection, a lot of their organs are affected and they are not back to normal. So this is something that you think through. Don't think I'm young, I'm strong, I have COVID, I recover, I go on with life as normal. You may not go back to life as normal. I think that's important. Okay? Now, so after answering infection and the symptoms and all that, what about the vaccine? We hear so much about vaccine, we ask so many questions about vaccine. What exactly is the vaccine? Okay? Now, vaccination itself actually was first started, the person who so-called started vaccination is Edward Jenner, okay, on 14th of May 1796. Okay, this date, Edward Jenner inoculated one of the maid's son, James Phipps, with cowpox because he noticed that those maids who have cowpox before, they don't get smallpox. So he took some cowpox solution and put it into the hands of James Phipps, this small boy. Okay? Now, a short while later, 1st of July, he purposely infected Phipps with smallpox. In those days, smallpox is a deadly infection. It kills people. But because of what he has done, putting small cowpox first, they found that James did not get ill. Okay? And from there, that's how we got vaccination. Means we infect a person with something that's more innocuous. Cowpox don't kill. Cowpox is just a mild infection. But it's close enough to smallpox that when you get smallpox, you won't get it. It's protected. Nowadays, we will not allow this kind of experiment. You can't take a child and do this, okay? You'll be sued off your pants, okay? But that's what he did, and he proved that the vaccination, cowpox prevents smallpox. This is the beginning of vaccination. And over the years, we have a lot of what called vaccine preventable disease. Two of the best examples is smallpox. Smallpox used to rage throughout the world. But once we have the vaccine for smallpox, I think all of us who are old enough will remember that, okay, the amount of smallpox infection came all the way down. So that by 1980, WHO declared that the world is free from smallpox. Okay, the world is free from smallpox. And smallpox is a deadly disease, killing a lot of 100,000 people per year before that. So this is one of the good effect of vaccine, okay? And polio, some of you may remember polio of days old. The picture down here on the bottom right shows what I call the iron lung. Iron lung is a mechanical device. Because of polio, it affects your breathing muscles, paralyze them so you cannot breathe. So those with polio who affects the breathing muscles, you put into this iron lung that gives some sort of vacuum, help you to breathe, okay? And they spend the rest of their life inside this machine. And that's how bad the polio epidemic was. They have this iron lung machine. Okay, we all learned about it in medical school. Thankfully, we don't have to go through this. But now, there are very, very, very few polio cases because we got a polio vaccine. Okay, and it's helped to prevent all this condition. Now, the whole problem or fear of vaccine started with this person. He's a doctor, Dr. Andrew Wakefield. Actually, he's a surgeon, okay? In 1997, he supposedly did an experiment and published it in the Lancet. Lancet is a very credible medical journal, to say that mumps, measles, rubella vaccine causes autism in children or increases autism in children. He was the first doctor who did this study and said, oh, my study shows that MMR vaccine increases autism risk in children. And this panicked everybody about taking vaccine. because autism was just beginning to be diagnosed and very, very hard to treat even to today. But subsequently, the paper that he did, Dr. Andrew did, was totally discredited because he did a lot of errors. He had financial reason for concluding what he did, and a lot of ethical violation he did in the paper, the study, so badly that he finally lost his medical license, and Lancet retracted his paper, took away this paper, says this is wrong. Subsequently, a lot of studies were done with MMR vaccine trying to see whether it affects autism. And so far, no study has shown that the vaccine can cause autism. But because this Dr. Andrew has put that idea into people's mind, a lot of people after that was very, very worried about vaccination, especially against the measles, mumps, and rubella because of his paper. Okay, everybody hear the first paper, but don't hear the part that is retracted and removed. Okay, I think that's important for us to understand. And this is a figure to show the millions of lives that have been saved by vaccine over the last 25 years. Tuberculosis, measles, meningitis, tetanus, whooping cough, hepatitis B, diphtheria, yellow fever. Okay, and these are the figures, okay, of people still dying from vaccine-preventable disease. Means 1.18 million people are still dying from TB, even though TB can be prevented with the TB vaccine, BCG, same as measles and all that. So we are still in the process, although got good vaccines, it's not reaching everyone. And these are, to us, life lost needlessly, that need not die. Okay, but because the vaccine has still not covered everybody. Something for us to know. So vaccine has a good role to play over all the years. I think that's important. Okay, these are the American figures. Okay, they just came out. This study got better statistics than locally. It says vaccine over the last 20 years have prevented 322 million illnesses, more than the entire population of the US. Avoided 732,000 deaths. Okay, and save a lot of money. So vaccine over the years have done a lot of good, and yet there are people who reject vaccine totally. Sad to say. Okay, there are some people who, my question I ask you, do you write off vaccine straight away? Some people do. My appeal to you is vaccine has saved a lot of illnesses and death. The figures are there. Okay, so don't just say vaccine does more harm than good. Scientifically, it's never have proven, despite many people trying to prove it. It has never been proven scientifically. I think that's important. And I'm thankful that Malaysia, this is our immunization schedule. Okay, BCG, hepatitis B, and all that. We are thankful as a nation that we are still doing immunization. But there are some parts of our society that try to avoid vaccination, and once in a while you hear of measles outbreak in this kampong lah, this town lah, and all that, because a group of people refuse vaccination, immunization, and that's where one case comes, it spreads to the rest. So my appeal to you is take the vaccination, even those that are given in our national immunization schedule. Okay, and this figure is to show you the amount of COVID vaccination done. As of this morning, okay, the latest figure, 236 million doses have been given in 103 countries. Well, that's Malaysia, okay, at the rate of about 6.67 million doses a day. This number of COVID vaccine already done so far, 236 million. And yet there are people who say the COVID vaccine is untested. If 236 million doses in 103 countries at 6.6 million doses a day is not tested, I don't know what you want to be tested. Okay, so keep that in mind. There are so people who go, untested lah, that's why I don't want to take it. Okay, these are the figures that we have. So we approach it in a very rational, scientific way, that there are so many million of doses already given and continue to rise. Okay. Now, what do you understand the COVID vaccine? I'll go into more detail here about the COVID vaccine. Okay. Now, remember this chart I explained to you how the COVID virus enters the body, hijack our system to make the viral protein and come back and multiply and be released. Okay. So the key to all the COVID vaccine is this part, the spike protein, the key and the lock, the receptor. This is the key for the virus to enter our cells, to enter our body. Okay, keep this in mind, because all our vaccine, okay, is dependent on the spike protein. Okay, a protein-based vaccine. Okay, what they do is, out of the virus, the whole virus, they just purify the spike protein, the part that's sticking out. They purify it, spike protein, and they inject it into your body, and that will cause antibody production. Okay, or viral vector vaccine. Okay, they take, because the COVID virus is the RNA, they take the RNA out and make it into a double-strand DNA. Why they do a DNA instead of RNA? RNA is very, very unstable. Okay, but DNA is stable. So they take the RNA, instead of single strand, they make it into DNA double strand. It's the same thing. Spike protein gene make the DNA, and they put this gene, the DNA gene, inside a virus, adenovirus, a flu virus, a common flu virus. Adenovirus vector is put inside. They inject into you. When inject to you, at the end of it, your body, because of the DNA, will form spike protein, and the spike protein will induce antibody production. Okay, or like what we now know about messenger RNA. We take the messenger RNA, okay, because we know the genome, take the code and cover it with nanoparticle, lipid nanoparticle to protect it, and then inject it into your body, and your body will produce the spike protein. So all of it is dependent on the production of spike protein within your cell, and this will activate your antibody production. I think there's a whole basis, okay, for the majority of vaccines that we are talking about. Okay. Now, one question that a lot of people ask me, the COVID vaccine is developed just too fast, therefore they cut some corners, cannot be safe. Let me explain to you why this need not be so. Okay, yes, you look at a chart like this, the typhoid vaccine took 105 years to be developed, polio took 47 years, okay, pertussis, whooping cough takes 42 years, rotavirus 33 years, HPV, human papillomavirus 22 years, hepatitis B took 16 years, measles 10 years, HIV we are still waiting for vaccine. Okay, all this took so long. Okay, and this chart shows the later one. MERS, after so long, no vaccine after 6 years. SARS-CoV-1, no vaccine after 17 years. Ebola, the vaccine just came out after 15 years. Okay, so where can the SARS-2 COVID-19 vaccine come back out within 9 months? This is a big question that many people ask. Okay, and I hope to be able to explain to you what's the reason. Okay, now this is the traditional vaccine approval process and time frame. How do you make a vaccine? That's important for you and I to know. Okay, firstly, there must be a concept. Okay, somebody think of something, this condition, we need a vaccine. And most of the time, all this starts in preclinical animal studies. You got this virus or this bacteria, they want to create a vaccine to, you try to experiment it in animals, okay, and see whether your concept, your idea can work or not. Okay, and this normally takes 2 to 3 years, okay, to explore your study in the animals and all that. After 2 to 3 years, you got to ask for permission to try to work on humans. Okay, there are authority in each country to be able to approve you to do human experiments. Okay, if your authority give you permission, Then you go to phase 1 trial. What is phase 1 trial? Phase 1 trial is you recruit normally less than 100 people to see whether the vaccine you are proposing, is it safe? Okay, the safety, and what dosage do you inject into a person, and what dosage, okay? So finally, the final question is it safe? So you inject the vaccine into about 100 people and see whether it's safe or not, to see it's safe or not. After the phase 1 clinical trial, which can take anywhere 2 to 3 years, as you recruit the people and study them, inject them and all that, then you're going to do your findings. The findings going to be resubmitted to the approving authority. They must check your findings and see everything is okay or not. If they think it can work, then they'll give permission to go on to a phase 2 clinical trial. What's the phase 2 clinical trial? Phase 2 clinical trial is you take about 100 to 1,000 people, okay? Safety considered, dosage you have found out, is it effective? Will it work to prevent a certain condition, a disease, okay? And it's normal phase 2, we do what called double blind. You got 1,000 subjects recruited, 500 will get the vaccine, 500 will not get the vaccine but get placebo, maybe sugar, water, whatever, okay? And see in this 500 who get the vaccine and 500 don't get the vaccine, what is the outcome? What's the outcome? Will they stick the infection? Will they not get the infection? Are they protected? So all this normally takes 2 to 3 years for the phase 2 trial, clinical trial to do double blind, to compare within one and the other. That's important, okay? After phase 2 trial, you'll go back to your authority to get approval, show the result and say actually it works like, it works in this percentage of people, that's why. And then the authority will give permission to go to phase 3 clinical trial. What's the phase 3 clinical trial? Okay, it goes higher number of people, 1,000 to 10,000. Okay, is it safe? Is it effective? And what are the side effects? Again, this is double blind. Means if 10,000 people, 5,000 get the vaccine, 5,000 don't get the vaccine, and see how they are they protected and all that. Okay, this is phase 3 trial. And phase 3 trial normally takes 2 to 3 years to be able to do phase 3 trial. Recruit the people, do the vaccine, and see whether infected or not. I think that's important. Okay. Then again, after the phase 3, you go to the authorities with all your figures, and if all the figures are good, okay, they may give approval. And the main approving body is FDA in the US, MHRA in the UK, EMA in the Europe. Okay, these are the main big people who approve vaccines. And most of the other smaller countries, although we have our own approval body, we tend to follow the big boys lah. Okay, because of their facilities and the means to do it. Okay, so normally FDA approved, a lot of people just follow suit and approve lah. And the approval process can take 1 to 2 years. And only if it's approved can it be marketed. And you after marketing, you got to do a phase 4 post-study. Okay, so this is the whole process, and this normally takes 1 to 2 years. That's why they say the normal vaccine approval process takes anywhere from 10 to 15 years. This is the normal timeline, okay, for vaccine to be approved. Okay, now for vaccine, the rate limiting step for a vaccine production from start to finish, there are 3 main rate limiting steps. One is finance. Okay, drug company will need to spend a lot of money trying to get the vaccine produced, test on people, pay them and all that, okay, to try to get the results. So finance is an issue, okay. So if there's no finance, everything moves very slow. Secondly, volunteers. How many can you recruit for your phase 1? How many for phase 2? How many for phase 3? That takes time to get a number of people, okay, to test, okay. Secondly, thirdly is technology. Do we have the technology to produce the vaccine that we want to try out on this disease? Okay, so these are all the rate limiting steps for vaccine production: the finance, number of volunteers that we can recruit, and the technology. Okay, now let's see this in terms of the COVID vaccine that took 9 months. Why did it take so short? Firstly, January, either the 10th or the 11th, depending which paper you read, China, who had the first cases in Wuhan, they were able to isolate the virus, and they are very kind. They give the viral genome online free. They didn't hide the information. Okay, so once they got the genetic makeup of the virus, China distributed worldwide for free, and that's very good for the Chinese government. Okay, because nowadays, once you have the genome, you can back manufacture the virus literally. You can put it together very easily. Okay, so once you got the genome, okay, then you can work on the genetic structure of the virus and try to figure out what to do. January, the genome was released. By May and April, Pfizer, Moderna, and Oxford, they already had the vaccine produced. You read the story of the Pfizer vaccine or BioNTech, actually the two key people, the husband and wife team of the BioNTech, okay, there's Turkish origin in Germany. They are so good, they've been studying mRNA for the last 20 years, studying that. They're hoping to use mRNA to control cancer. But when the COVID came on in Wuhan, and he got the inkling that this is going to be a pandemic, okay, according to some papers you read, the husband and wife team, okay, overnight, on one weekend, from the genetic structure of the COVID virus, he roughly knew which is the portion that codes for the spike protein. They are that good. And within 2 days, they can produce a vaccine against this. That is the technology we have, Okay, so in March and April, both Pfizer, Moderna, Oxford already were ready to start phase 1 trial. Okay, and they talked about 50 to 100 people to answer the question, is it safe? And before the phase 1 trials were completed, they were so confident, and the authorities gave them permission, okay? They started phase 2 trial, okay, within 2 or 3 months. Before the phase 1 started, completed, phase 2 trial started with 500 to 3,000 people to answer the question, is it effective? Okay, and before the phase 2 trials ended, permission was given for phase 3 trials, 20 to 40,000 people, to see how effective and safe it is. So all the phases were compressed because the figures that were initially coming out were so good and so strong. Okay, that all those who got the vaccine were being protected. Okay, so that's important. So even before all the phase 3 results were out, they were already building factories for phase 3 supply. Before the phase 3 started, they built the factories to manufacture the doses, okay, in 100,000s, in millions. That's why it's so fast, okay? And they started producing and expanding all the factories even before the phase 3 trials were finally approved, approved. So the approval submission was late November, 2nd December for Pfizer, Oxford, AstraZeneca, Moderna. Within that period, they all submitted their reports from the phase 3. And that's how fast it is. And once the approval came, distribution goes straight away. And that's why it took 9 months. 9 months. Because the technology was in place, okay, they were very ready, and they concurrently overlapped the phase 1, phase 2, phase 3. They still did the test, they still had the study, but because they are so, the initial results so good, they proceeded and combined everything together. And they were building factories and production expansion, all with the understanding that the need for it is so great. That's why it's so fast. Okay. Now, this is what I've just explained. Okay. Phase 1, phase 2, phase 3 overlap. Approval came, and it happened so fast within 9 months. Okay. Now remember the great limiting step that I talked about. One is technology. Okay. So because the COVID-19 is a coronavirus, and we know a lot about the coronavirus because of SARS and MERS family, same family. There's a lot of overlap in the genetic structure, okay? And because scientists have been studying the MERS, so whereas the coronavirus, they roughly knew which part of the genetic structure codes for the spike protein. Okay? For SARS and MERS, frankly, the technology to produce a vaccine technically is there, but there's no money to be made because there's no SARS epidemic, there's no MERS epidemic. The disease died by itself. So what for make a vaccine that there's no need in the world? Okay, but COVID is an ongoing one. So the technology just fell into place for COVID-19. That's important. Secondly, the finance fell into place. A lot of countries were pumping billions of US dollars, and some of them buying ahead of time, 100 million doses and pay upfront to fund Moderna and all that. Pfizer did not take money from the government. They say after we produce, proven, approved, given, then you buy from us. Okay, Moderna took money upfront from the US government and all that. So the finance was there. So finance, money was not a limiting factor for COVID-19 vaccine. Thirdly, volunteers. In the pandemic, okay, it's so easy to recruit not hundreds, thousands, but tens of thousands of volunteers to try the vaccine. People were lining up to test the vaccine. You see, the Pfizer biotech vaccine, the first volunteer off the record was the biotech, the two husband and wife team. They injected their children, okay, to see how it works. That's how confident they were of their vaccine. So to me, the COVID-19 vaccine approval came so fast in 9 months because it was the perfect storm. Everything fell into place. The technology was there, the finance was there, and the whole crowd of volunteers. Because of the pandemic, a lot of people were getting infection. So what takes 2-3 years to get a number of figures? Suddenly 2-3 months, you have the figures. Okay, they tell me now in China, because the COVID numbers in China is so low, okay, China has come up with a treatment for COVID. They can no longer test in China because there's not enough infection cases in China. So they go to other countries to test. Okay, that shows the importance of number of volunteers during a pandemic. When numbers are controlled so low, you test 10,000 people, the chance of them getting infection is so low because the whole country now is so low. Okay, so that's what you need to know. And that explains, I hope, to those who are so frightened of taking the vaccine because it's produced in so short a time. This is the main reason that I need to explain to you. Okay, now the Malaysian COVID vaccine strategy, we talk about spending 504 million US to try to immunize 26.5 million people, 80% of population for herd immunity. Okay, the other 20% is those below 16 or 18, depending which age group you see. Okay, so we are trying to immunize everybody. We have gone for the Pfizer biotech that's come into the country. We also paid for the Oxford AstraZeneca from UK direct or from India. Okay, Sinovac has just come in as well. China CanSino virus, the single dose virus, as well as the Russia Sputnik 5 virus. Okay, we have so-called committed to buy all this virus, this vaccine, not virus. Okay, and we are in talk with Moderna and Johnson & Johnson. So these are the vaccines that we are covering, that I will cover. Now, how does the COVID vaccine work? How does it work? Okay, now go back to the same picture that we have. Okay, we talk about Pfizer biotech vaccine first. Okay, now this is the virus diagrammatically. This is the viral genome. And we know that this red portion is what I call the spike protein gene. Means this portion of the gene causes the spike protein to be made. So what they did is they isolate this portion, or just make this portion. Okay, make this portion, and they code it within a lipid nanoparticle. Now, why you need to code it within a lipid nanoparticle is if they just take the spike protein and inject into a human being, straight away your antibodies in your body will destroy this mRNA. mRNA cannot last well injected into the body. Okay, it cannot last. So you straight away degrade and die and be eaten up by your antibody cells. Okay, so they coat this with lipid nanoparticle to protect it from, as I said, being injected, and also inside the lipid nanoparticle, the mRNA is more stable. Like I said, RNA is very unstable. That's why it got kept in so low temperature, 70 or 20 and all that, because it's very unstable. Once this is injected into a body, what happens is, once the nanoparticle with the mRNA is injected, the whole particle is taken in by the cell. Your cell only will absorb it, okay, attacking it as it were. Once it's inside the cell, the RNA is let loose. This RNA is let loose, and because your cytoplasm, the cell has ribosome, straight away the ribosome will go to work reading the mRNA and start producing the protein that will become the spike protein. Spike protein is a 3D model. 3 spike protein will combine to make the whole spike. Okay, it's a 3D model. You can imagine it. Okay, so once the mRNA enters, your ribosome will go to work and start making all this, and the spike protein will start being produced inside the cell. Okay, and what happens is, you produce big enough, it will start sticking out of the cell. The cell itself will start having the spike protein sticking out, and some of them remain in the cytoplasm, and sometimes this cell after a while will burst. What happens after it bursts? Once it bursts, the spike protein will go into your tissue, and we have cells that pick up this spike protein and help us to produce antibody. Okay, or helper T cell, B cell, don't worry about it. Once we have this spike protein in the body, you'll start producing antibody. Okay, and once antibody is produced, if any time another COVID virus comes in, straight away the antibody will kill it. Or if it doesn't kill it, we are under T cells will come and literally eat it up, because it's been synthesized. Big sensitive to it, okay? So Pfizer BioNTech is 2 doses, okay, 3 weeks apart, and the efficacy from their study is 95%. Okay, 95%, which is very, very good for vaccine. Our normal flu vaccine that we give is on 40 to 50% only. Okay, so it's very high. So this is how the Pfizer BioNTech vaccine works. Okay. Next one is the Oxford AstraZeneca vaccine. Okay, so the same virus as such. Okay, what they do is they take the RNA from the COVID virus, convert it into DNA. DNA is more stable, so it don't need to freeze so cold. Okay, and they put this DNA inside an adenovirus. Adenovirus, the flu virus. Now, Oxford used a chimpanzee flu virus. Why they use a chimpanzee flu virus is, then people like you and me, people will not have that virus with you before, because it's among the chimpanzee. But they have made the chimpanzee adenovirus unable to replicate. Means they can inject the chimpanzee adenovirus into you, you will not catch the flu, because they make it unable to replicate. It's just there. Okay, they have done this. This is all technology. That's all tested technology. So once you inject this virus, adenovirus, with the COVID DNA inside, you inject your body. Again, the body will eat it up, open its big mouth and eat up the thing. And once it's inside the cell, the DNA, the virus will open up, release the DNA, and DNA will actually enter your nucleus. DNA enter nucleus, and in the DNA, out of it will come mRNA. This is a natural process. DNA will proceed on to make mRNA, and mRNA will not stay in the nucleus but come out into the cytoplasm. And one is outside the cytoplasm, it will do its work. Okay, it will do its work like the one the Pfizer did. Once you have this mRNA in the cytoplasm, you start making spike protein. Spike protein will be produced, and you'll come out, like just now that one. Okay, now after this is the same thing again. Same thing again, the same pathway, the antibody will be produced by different cells, okay, and you'll be able to attack the virus if it ever comes on. So it's good for us to know that once the spike protein is produced, the activation, the antibody is all the same, okay. So AstraZeneca efficacy is 82.4%, okay. First dose and second dose, you may heard about the half dose and the full dose. You are keen to know why the half dose is more effective. You can ask me after that, okay. There's a reason for it, okay. So this is the same pathway, and the same pathway for the Sputnik 5, the Russian vaccine, okay. Same, the virus is there, but the Russians are a bit smarter, okay. They do what we call two viral vehicle, okay. The first dose, they use adenovirus 26. This is the human adenovirus 26 flu vaccine, flu virus. Second dose is adenovirus 5. All these are part of our flu vaccine, human adenovirus. Again, they make sure they cannot replicate anymore. They convert the RNA to DNA and put into adenovirus 26, adenovirus 5. Okay? Then the same thing was injected to you, the same thing happens. The cell will take in, DNA comes out, make RNA, RNA goes out, and RNA itself will start doing the spike protein trick. Okay, and this will do all the antibody production. I think that's important. Okay, so in the Russian Sputnik vaccine, okay, the first dose you get will be blue color tabs. Blue color tab is adenovirus 26 as the vehicle. The second dose is slightly different. 21 days later is the red color tab. This adenovirus 5. The reason why they use two different adenovirus is that after the first dose, your body will attack the adenovirus itself. So the second dose, you use the same thing, it will be less effective. So they trick it with another adenovirus that's not the same. So the response efficacy rate is 91.6%. That's very good and very high. Okay. Now, the other vaccine that we are buying is called the CanSino vaccine. Uses the adenovirus 5 as a vehicle, but it's a one-dose vaccine, One-dose vaccine, efficacy is 65.7%. Also very good. Okay, this is the only one-dose vaccine that we are buying. So far, I have not bought the Johnson & Johnson yet. Okay, there's also one-dose vaccine. So this explains how the vaccine works. Okay. Now, the other vaccine is the Sinovac vaccine. Sinovac vaccine is slightly different in action. This is the virus. What the Chinese have done with the Sinovac vaccine is they destroy the gene of the virus with a chemical, okay, beta proprolactone. Okay, they destroy the gene, but they don't destroy the structure. So it's an inactivated virus, means it cannot produce anymore. But the outside spike protein, all that are still there. Okay, that's what they have done. They inject this into your body. Again, the cell will come in contact with the spike protein and produce antibodies to the spike protein. Okay, once the antibodies, straight away, if any virus comes, it will attack and kill it. So this is the old-fashioned inactivated coronavirus vaccine, Sinovac. Okay, that a lot of people are comfortable with. Now, I'm going to put a statement out that I took from Gavi. Gavi is the Vaccine Alliance recognized by WHO. Okay, what Gavi has stated in their Q&A in their webpage is, inactivated vaccine only stimulate antibody-mediated responses, B cell, but not the T cell response. And this response can be weaker and less long-living. Okay, which means that because of the way it works, it only stimulates, we think, one arm of the antibody response, the B cell that produces antibody, and not so much the T cell. Okay, that's more complex, but they did make a statement in their web page. Okay, good to know and keep in mind. Okay, and Sinovac, depending which study you read, effectiveness, efficacy comes from 50% to about 60-65%. depending from Brazil or from Turkey, the study and all that, slightly different efficacy figures are quoted, but they're all above 50%. Okay, that's why they can be sold. Okay, sorry. Side effects of COVID vaccine. What are the side effects of COVID vaccine? Let me run through it. Okay. Now, in any injection, there will be local reaction, there will be systemic reaction. Any injection, cure of pain one. Okay. So these are the age as well as dose 1, dose 2, slightly different reaction. Okay. So pain is one, swelling and redness on the injection site. Any injection you get this. Okay. So take note of it. That's acceptable. Okay, and expected. Systemic reaction of fever, tiredness, headache, chills, muscle pain, joint pain, these are major ones. Okay. Now you notice that some of them, the fever, okay, after dose 2 tend to have more fever than dose 1. And this to be expected because dose 2 is stimulating, your antibody already stimulated. So the second time you inject, you expect more reaction. Okay. Fatigue as well, headache, and so these are to be expected with any vaccine. Okay, and these are the figures I quoted from side effect of Pfizer. They are good enough to publish their figures. Okay, any vaccine that we get, whichever vaccine, we expect some of these side effects, systemic reaction. Okay, and this a lot of times shows that the vaccine is working as it should. That's important for us to know. Okay, so keep this in mind. Now I need to make a statement here. Correlation is not causation, and this is something that we need to understand and come to grips with if you want to talk about vaccine. What do I mean? Okay, correlation does not imply causation. Okay, refers to the inability to legitimately deduce a cause and effect relationship between two events or variable solely on the basis of an observed association or correlation between them. What this means is, let's say COVID vaccine. I inject you a COVID vaccine now. Next week you die. Does it mean that the COVID vaccine that injected you killed you? Okay. Correlation does not imply causation. You die next week need not mean that the COVID vaccine injection killed you. Or I like to use the example. During this pandemic, a lot of us gain weight. Okay, because of a lot of other reasons. If we talk about correlation and causation, can we then conclude pandemic equals gain weight? Does it mean the pandemic caused you to gain weight? Now we all know that's not true. But a lot of people make this correlation. A doctor got this injection, 3 weeks later, he died of a stroke. Does it mean that the vaccine caused the stroke? Or is there some other reason? So keep this in mind. I think that's important. And I'll share with you some examples, okay? Bell's palsy to COVID vaccine. This has been the highlight. You see videos on it, figures on it. What is Bell's palsy? Bell's palsy is one-sided weakness of the facial nerve, okay? Causes asymmetry, a sagging face. This is called Bell's palsy. It's idiopathic. Idiopathic means we don't know the cause. Until now, we still don't know the actual cause of Bell's palsy. Okay? Is it related to COVID vaccine? Let's share some facts with you. It's the most common unilateral facial paralysis. Okay? Most of the time, 80 to 90% of cases will get well by itself within 6 weeks to 3 months. Okay? Some have residual effect, we don't know why. So 80 to 90% will get well 6 weeks to 3 months. Okay? So it's the most common neurological disorder affecting a cranial nerve and most common facial paralysis worldwide. So it's more common in adults, diabetics, and pregnant women. So these are our statistics. We know about Bell's palsy, and these are what we know about Bell's palsy at present. Okay, so the general population annual incidence is 15 to 30 cases per 100,000 population. These are the normal figures. that we see Bell's palsy. I'm sure some of you may have Bell's palsy and recovered. Some of you will know of people who have Bell's palsy and recovered. Okay. Now, when we talk about Moderna and Pfizer vaccine causing Bell's palsy, these are the figures best I can find out. Moderna vaccine, 3 cases had 1 placebo had. Pfizer, all the 4 cases were in the vaccine group. So people say, hey, see, the vaccine caused Bell's palsy. Okay. Now, these figures compared to the number of subjects that they have, the number of people who took the vaccine, it works out to a combined incidence of Bell's palsy of 17.7 per 100,000 population. 17.7, which is within the normal occurrence of Bell's palsy. Remember correlation and causation. Just because after vaccine you get this does not mean the vaccine caused this. Okay, and Bell's palsy, the figures are like that. We are getting 17.7 per 100,000, while the normal population figures are 15 to 30 per 100,000. Okay, so keep that in mind. Same as allergic reaction to COVID vaccine. Allergy is very, very common. 1 in 12 children have food allergy. Every year got 150 to 200 fatalities from allergies. A lot of them from bee stings, okay, drug allergies, okay, all this is very, very common allergy, okay. So on top of anaphylaxis reaction to vaccine that many people are very frightened of. Question, why were they not detected during the phase 1 to phase 3 trials? Okay, some people ask that question. And then anaphylaxis, okay. I think the reason why it's not detected is a lot of time phase 1, phase 2, phase 3, when they do the trials, they try not to include people with known allergies. Okay, it means they take people without any known allergies. So if they are excluded allergic people, then you're unlikely to pick them up. Okay, that's one. How frequent are severe allergic reactions just to normal vaccine? Don't talk about COVID vaccine, to normal vaccine. This one we know, 1 in 1 million injection will get allergic reaction. Normal vaccine. Okay, in the normal everyday sense, 1 in 1 million. Okay, so how frequent is this reaction in COVID vaccine? It's about 1 in 100,000, 10 times more. 10 times more. We do know these are the figures. Okay, so there is a component. Okay, we are trying to distinguish what and what. Now, the normal UK hospital admission for anaphylaxis for children, okay, is 2.4, about 2.4 per 100,000 children. That's the figure that we have for anaphylaxis in UK for children less than 18. Okay, now the number of anaphylaxis from vaccine, Moderna, Pfizer, Oxford, Zeneca, okay, it works roughly to 0.22, 0.41 or 1 per 100,000. Okay, these are figures that we have, 1 in 100,000. Okay, so there is in a way a concern, but normal anaphylaxis in children is actually higher. Something we want to take note of, but it's not something that we push off. We understand, and how we treat it, I'll explain to you a bit later. Now, this article was just sent, okay, a few days ago. Peanut allergy affects 30,000 people per million. This is a worldwide figure. Okay, now, this is 10,000 more common than vaccine. Okay, vaccine talks about 1 per million. Okay, but peanut allergy is 30,000 per million. Okay, so it's much more common for peanut allergy. And now this peanut allergy, 1 in 200 cases of peanut allergy actually die. Okay, this is one of the reasons why airlines is no longer serving peanuts. Because at one time, a lot of people took peanuts on the plane. Okay, got anaphylaxis and they died. Okay, of reaction and they suffered. Okay, so peanut allergy is very, very common. And some people die from it. But nobody says, but we will stop eating peanuts, stop selling peanuts. Okay, it's a known allergy. Those who are allergic to it, don't eat it. That's what we are saying. Or if you're allergic to it, you do what called EpiPen. EpiPen is a very expensive adrenaline pen that you carry with you. You got anaphylaxis, you just jab it, it straight away reverse the reaction. Okay, so a treatable condition. Okay, I think that's important. So far, I think as far as I know, the COVID vaccine anaphylaxis, nobody has died from anaphylaxis. They've been treated and they respond. Some a bit slower, some a bit faster. I think that's important. Okay, so allergic reaction to which part of the vaccine? This is the million-dollar question. We are not sure, still unclear. Is it the lipid nanoparticle that everyone talk about? That this causes allergic reaction? We are still not sure. If it is, then whether it can be overcome, we are not sure. Okay, or is it a stabilizer within the vaccine itself? Okay, PEG is the most common that you use. Some vaccines slightly different ones. So we are still not sure which part of the vaccine causes this allergy. Work is being done. Okay, so how do we address this allergic problem that we have? We are aware of it and we try to overcome it. Okay, so the answer is people with history of severe allergic reaction, especially if you got anaphylaxis before, you don't take the vaccine at present. Not at this time. Don't take the vaccine, okay, because your risk goes up. Second, people with no allergies and you still take the vaccine, you wait for 15 to 30 minutes in the center that injected you after vaccine. Nearly 80% of the allergic reaction will happen within 30 minutes. Okay, most of the time, immediate 5 minutes, 10 minutes, at least within 30 minutes. So you see the protocol. You have to stay there for 30 minutes before you can go out. So if anything happened to you, they know how to treat you in the proper setting. I think that's important for each of us to know. Okay, now you recognize that the mRNA vaccine, Pfizer and Moderna, do not use any egg culture, gelatin or latex. The old-fashioned way of doing vaccine, they grow the virus inside a medium. A lot of times it's egg. And after they have grown, they try to purify it. They try to remove as much of the egg as possible. But some of it still remain. So some people are allergic to egg, you cannot take the vaccine because part of the egg is there. Okay? But the mRNA is purely genetic. And they know exactly what they put in. So in a way, it's much pure form than the old way of making vaccine. That's important for us to understand. Okay? Now, there's a lot of unanswered question for COVID vaccine. Okay? What about ADE? What's ADE? Okay, you may ask. Okay, so ADE is whole area of antibody-dependent enhancement. A big word. Forget about it. It don't affect you. Is that sometimes the vaccine can just stimulate your body, so the next time you have the infection, it makes it worse. Makes it worse. Okay. Now this is very well known in dengue. Okay. The fiasco with the dengue vaccine was, we think, all due to ADE. Okay. So dengue fever, we know very well there are 4 main types of dengue. 1, 2, 3, 4. Now some people talk about 5 types of dengue. Okay. So if you have been infected once with dengue, okay, you survive most of the time, no problem. But you get a second dengue infection, we know that the second dengue infection can be more dangerous, can more likely to get hemorrhagic bleeding. It's a well-known thing about dengue, and we assume and we attribute it to what I call antibody-dependent enhancement. Means your antibody is there, but not strong enough to kill the virus, but actually make the virus worse. Literally, that's what it means. And in the lab, they have done studies with RSV, respiratory syncytial virus, measles virus, SARS, and CoV. They can roughly duplicate ADE reaction. But so far on the COVID virus, they have not been able to duplicate it. Okay, and that is reassuring. So I think it's important for us, okay, that thus far we have not been able to see any ADE. The scientists and doctors are looking out for it. It's a theoretical possibility, but so far we have not seen it, despite the number of people who had the infection and the number of vaccine being used. Okay, so far it's a theoretical risk that we have, but it has never been proven as such, okay, in any clinical setting. I think that's important. Now, theological, ethical issues, not many of you are worry about this, but just use it for completeness sake. Okay. Now, the use of cell line for aborted fetus, we all know about it. Okay, not everybody's very good at HEC 293 per C6 and all that. All these are used, okay, from cells that have been cultured and kept alive all these years. Means in the petri dish, they got eternal life. The cell, they can continue to grow the cell, and use the cell for experimentation. Okay, actually, a lot of this is used in vaccine already. As I said here, rubella, hepatitis B, okay, and chickenpox and all that are using these cell lines. But in those days, nobody made any noise about it. Okay, certainly with COVID, everybody is so worried about these cell lines, aborted fetus. I don't feel nice, theologically, ethically to use it. Okay, just to reassure ourselves, okay, the Catholic Church in Singapore and Malaysia have put out a statement on COVID-19 immunization and the cell line thing. Okay, encouraging people to say you can use it, you can use it. And CCM just put out a statement as well 2 days ago to encourage people to be vaccinated. Okay, I think that's good to know that the church is encouraging. Okay, now at the end of it is a very personal, theological, ethical understanding, conviction, and decision to make if you are worried about it theologically, ethically. And my best example for you is this. This is a picture of a Roman road. Okay, Roman road. Now, you know the Romans, okay, during the time of Jesus, the Romans were not the best of conquerors. Were they the gentlest of conquerors? A lot of these roads were made from forced labor and slaves. Means literally they take the slave and make the road and pave the road. Okay, do we believe in slavery? No, we don't believe in slavery. Okay, but if you don't believe in slavery, then you ask the question, if this road is made by slave, should I travel on it? Should Paul, the great evangelist, missionary, should he have traveled on these roads since they were made by slaves? Okay, a question worth reflecting. Same thing as the railroad line in America, maybe not in Malaysia. In America, a lot of these railway lines were made by slave labor. Okay, slave labor. So as Christians, should we be traveling on the railway lines since they're made by slavery? We don't believe in slavery. We should not. Okay, so to me, it's in a way, it's not a question. Doesn't mean that we use the vaccine, we condone abortion. Okay, but it's something done in the past. There's no way for us to undo it. But it's something that helps us keep that in mind. So the Christian approach to COVID pandemic and vaccine, for some of us to consider that we have vaccine that are promising, okay, but that is not the promise. For Christian, the promise is in Jesus Christ alone. Okay, so vaccine, yes, there's promise to help us, but that is not the promise that I talk about. But for us Christians, the promise must be in Jesus Christ alone. So you may ask about this COVID mutation. What is it all about? Okay, yes, we know about the UK mutation B117, the UK variant. They tell exactly which part of the gene is mutated. Okay, now got all these three, not the UK one, the South Africa one that's very bad, and Brazil. And this mutation will continue to happen. And it's a feature of viruses to mutate. Okay, the reason why we have flu vaccine every year, actually if you bother, we have flu vaccine every 6 months because northern hemisphere winter different from southern hemisphere winter. So we try to predict which will be a prevalent flu virus for that season. We try to predict. Some years you get it right, some years you get it wrong. So you get it right, your flu vaccine works better. You get it wrong, your flu vaccine doesn't work so well. Okay, and same with the COVID vaccine, COVID virus, it will continue to mutate. So what do? We are so worried. The best solution for this mutation is to get people immunized as quickly as possible. Once you are vaccinated, you no longer, in a way, harbor or transmit the infection. You won't get the infection yourself. Okay, and because you don't get infection yourself, the virus itself cannot how to put it, infect you and mutate within you. So the less people having the infection, the chances of mutation goes down. That's why you need to get as many people vaccinated as soon as possible. As soon as possible. Okay. One question about treatment options. Okay. People have asked me, ivermectin, a very cheap anti-hematic drug, hydroxychloroquine, malaria drug, or used for rheumatoid arthritis. These are cheap drugs. Why don't we use it? Okay. I must say that ivermectin works very well against COVID vaccine, COVID virus in the lab, in vitro. But so far, the clinical studies do not show ivermectin as effective as it's claimed to be. It may have a place for mild or early time to suppress the virus initially, but it does not make any difference in severe, moderate, or death. All the studies that they have, it did not show any improvement. It may have effect for very early part of the COVID infection. Okay, tests are still going. So it's nothing to do with big pharma, no money to make. That's why they don't use it. Okay, best as I can tell, all the literature, ivermectin will help initial part, but it does not make a difference in the severe and the death rate. Okay, hydroxychloroquine had a lot of promise initially, but subsequently everybody says it does not work, full stop. Okay, you can check all the papers and all that, it does not work, so it's out of the equation. But some countries are still using it because it's cheap and you have something to give people. And hydroxychloroquine itself has side effects. Okay, so that's something to keep in mind as well. So just to put a note about this. Now, facts and figures about COVID vaccination, that I must bring it up. The best country to look at is Israel. Israel has done the most number of vaccination in the whole world, country by country. Okay, this is a few days old already. Okay, nearly 50% of their people have been immunized. Okay, now the reason why they can do it so fast is Israel is a small country, I think about 8 million people only. Okay, they make a deal with Pfizer, okay, that will pay a good price for your vaccine. They pay double the price as compared to EU, okay, and Pfizer promised to give them enough vaccine to vaccinate, I think about 90 or 95% of the population. That's the amount, okay, and Pfizer's only requirement was the whole population of Israel, the effect of the vaccination, the whole data is shared with Pfizer. It's shared with Pfizer. So Pfizer can use it for publicity. Okay, and Israel has a very good computerized health system. Means all their people are on record. Who is vaccinated, who is not, who is vaccinated, who is not. They got all the good record. Okay, so the population, they started on the 20th of December, population about 8 million, 8.9, something like that. 40% already had the first dose, 28% second dose. Of those 60 years and above, the high-risk group, 80% have already gotten the vaccine. That's how progressive they are, okay? And you look at this, 60%, all the 60 years old were first vaccinated by mid-January. 56% drop in cases, 40% drop in hospitalization, 35% fewer deaths. Okay, Maccabi record. Maccabi is one of their healthcare providers, all computerized. They said out of the 500,000 vaccinated, only had 544 cases, 0.1%. And of these 544 cases, only 15 were hospitalized. 8 mild, 3 moderate, 4 severe, and none of them died. And they compare on their record with an unvaccinated population of 628, those who had not got the vaccine. Out of these 628 people, 18,425 COVID cases as compared to 544 cases. That's how good their record is. That's how good their vaccination is. And even now, Israel is slowly trying to open up because their cases have gone down dramatically with their vaccine coverage. Okay, I just received this 3 days ago actually. This is a summary of all the phase 3 trials Johnson & Johnson, Pfizer, Moderna, Novavax, Sputnik, the Russian vaccine. The important figure to see is here, 100% protection from death and hospitalization. Means all of them protect against severe COVID. That's how good the vaccine is. If nothing else, if you don't get the vaccine, you get the infection, but don't get severe and don't mess up the whole hospital system, it makes a big difference. Okay. A word about efficacy and effectiveness. I'll just explain this. Efficacy is what you get when you do experiment, like phase 1, phase 2, phase 3. They know the efficacy, they calculate result because in a controlled environment. They know people with allergies do not take part. People who are pregnant don't take part in this experiment. So they know 100 people, 1,000 people. Then they can calculate how efficacious this vaccine is in this population. Effectiveness is when the general population start getting the vaccine. Okay? In the general population, it's no longer a controlled environment, but the general population. So you see more allergy reaction, you see more reaction and all that, okay, to the expected. But I must say that the Pfizer vaccine, if the Israel figures I already go by, Pfizer says their vaccine is 95% efficacious in the controlled environment. Their start data. So far, the Israel using Pfizer vaccine has shown 94% effectiveness. That's how good it is to correlate from a controlled lab experiment with the open world that using it in the general population. I think that's very impressive, I must say so. Okay, now this is a group of doctors, okay, to preempt the anti-vaccine propaganda. Now they say US death rate for people 65 and above is 3,917 per 100,000 population. US, because got better statistics, and the most common cause is heart disease, stroke, cancer, and lung disease. Okay, for Malaysia, okay, our statistics show that for those who are more than 65 years old, 4,000 people die per year for every 100,000, which works out to 75 people will die every week of those 65 and above. Okay. Statistics department tells us that 7.1% of our population is more than 65 years old, which means that 2.34 million of our population is more than 65 years old. That's important, okay? Which means that if we take this figure, we expect for Malaysians more than 65 years old, 1,755 deaths per week, even without COVID-19 vaccination. And this is what we call a baseline death every week. So when we start injecting people, especially older people, and people do die, like what happened in Sweden and all that, okay, does not mean correlation and causation. Doesn't mean that this person got a vaccine, 2 days later, 2 months later, he died. It's caused by the vaccine. People will continue to die with or without the vaccination. Okay, but we are trying to prevent the COVID infection that kills more people. After saying all this, the greatest danger to me to COVID vaccination is not so much the virus or whatever. The whole danger of COVID vaccination is whole area of what called infodemic. What is infodemic? You may not have heard the word. Infodemic is abundance of information, both online and offline. A lot of information online, WhatsApp, Facebook, Twitter, Instagram. And because of COVID pandemic is the first in history where this technology and social media is so used, so available, that we cannot separate fact from fake. Fact from fake. We can't separate it. And that is the danger. Okay, so infodemic includes the deliberate attempts to disseminate mis- and disinformation, to undermine the public health response, and advance alternative agendas of individual groups and individuals. This to me is more dangerous. Okay, so it can be very harmful. We spread things that we are not sure of Fake news we send happily to our friends, and everybody get very worked out, everybody very worried. One example, you may not be here, but it's quoted in a US thing. Okay, people talk about luciferase and the COVID vaccine. The COVID vaccine, there's luciferase inside it. Okay, and because the word luciferase sounds like Lucifer, so people say this is all the evil that's there. But actually, luciferase is just an enzyme that uses for this flower fly to give this glow. Okay, it's just part of the medical study to see reactions. Okay, but people, because they see luciferase is there, the name sounds like Lucifer, they think it's all evil, and this can be spread and all that. This is just one example. Okay, one example that can be taken off with infodemic, and that becomes a danger. Okay, so be careful. There are a lot of myths and stories out there, fake news out there, and a lot of traditional cures, all kind of cures. I've heard all kind of things. Okay, now unless they are subject to controlled experiment, we do not know whether they work or not. We are not saying all of them are wrong. Okay, but because we believe in this, and because we believe in this, we avoid the vaccination. Then whether you're doing ourselves a favor or disfavor, something for you to decide on your own. So my advice is fact check, fact check, fact check. A lot of the stories going on, sometimes I get bored. You got to fact check it on Snoops, fact check it on Reuters, and different sites, fact check. They'll tell you the actual story. So if you are careful, this person didn't send a rumor to a group chat, it stops. After second time, you check again, it stops. So we need to be such people that verify before we forward. And it will help a lot of infodemic that's causing more harm than good for our nation and for our people. Okay, so as the national COVID-19 immunization program is starting, it will be free for all. Okay, I hope me and my wife have registered within the first hour on Sejahtera. That's how kiasu we are. Okay, and that's important for us to get ourselves protected, not only for our own sake, but if we don't get infected, we hopefully cannot pass on to the next person who may not be so fortunate, age-wise or comorbidity. Okay, that's important. That's important for us to consider, not only for yourself, but for others in your household. And this, you see the schedule when they tell you to get injection. Okay, you receive the shot after seeing a doctor consent form. 30 minutes of observation to look out for side effects, especially anaphylaxis. Okay, it's all built into the system, so we are aware there is side effects. We are aware of allergic side effects, and that's why all this is built into the system. Okay, and that's important for us to do our part to help to stop and stem this COVID pandemic. Okay, so with this, it's a long talk. I'm quite sure you're all not so happy in my voice anymore. Okay, I'll stop here and take any question that you may have.
All right. There is a question. I think you dealt with ADE, the antibody-dependent enhancement. There's also a similar question to ask that would there also be the Trojan horse mechanism?
Okay, the Trojan horse, a lot of people talk about adenovirus as a Trojan horse. Okay, now, what we know about adenovirus is also used in other vaccines, and it does not cause adenovirus to multiply within us. The mRNA is not very, it's actually very fragile. It doesn't last in the body. It will degrade and be gone. DNA that the adenovirus capsule encapsulates, okay, is just the part of the spike protein, not the whole protein. Okay, so whether you get the more logical question is whether you get long-term autoimmune disease. I think that's where everybody is pointing to. Okay, now this is one question that we cannot answer because the vaccine is so new and the condition is so new. Even the whole aspect of autoimmune disease, we are not sure exactly how it develops. Okay, so I always tell them, it's a theoretical possibility of long-term autoimmune. It's theoretical possibility, same as ADE. Okay, but would you be worried about theoretical risks that may or may not happen, but in the meantime, expose yourself to COVID infection that we know can happen? And somebody just show me a graph. By tomorrow, they said by tomorrow, March, at least 1% of our whole population will have got COVID infection. 1%. They said by tomorrow, they said 1st of March. Okay, the way the graph is going. So COVID infection is a reality now. To worry about theoretical possibilities of long term and be paralyzed by it, and because of the theoretical possibility, I don't get the vaccine now. Okay, if you belong to a high risk group, above 65, overweight, hypertension, diabetic, and you get the infection, let me assure you, your risk is very, very much higher than the theoretical possibility that may be 10, 20 years down the line. Okay, so I think we must take things in perspective. Some people are very worried about theoretical possibilities. Yes, it's possible. Okay, and nobody says cannot because it's so new. But it's all theory, and so far the scientific papers that we have do not seem to indicate that mRNA is very unstable, it will not last. DNA enters the nucleus, all it does is give the mRNA for spike protein, nothing else. Okay, I know that there are a lot of stories being told that you change your DNA and become a chimpanzee because the chimpanzee adenovirus. Okay, that will not happen. That will not happen. Okay.
Okay, thank you, Pastor. Okay, there's another question. I know that you have dealt with what are people with comorbidities or underlying disease, and that perhaps some of them should not be taking the vaccine for the time being. So there's a question here about what about taking steroids, for example, to suppress immune system due to autoimmune disease. Should a person consider taking the vaccine? That's number one.
Okay.
Question number two, what about thalassemia?
Okay, let's take the easy one first. Thalassemia, no problem. You can go ahead and take the vaccine. Okay. Now, if you're on steroids, okay, then it's better for you to consult your doctor. You must steroid for a reason. And steroids itself can lower the effectiveness of the vaccine. Okay, so it's better for you to consult your doctor. Okay, so we do know that those are immunosuppressive. Okay, your response to the vaccine is not as good. So steroid is one of them. So it's better for you to consult your doctor because the individual case. Okay, we do use steroids now, dexamethasone, for severe COVID is proven to help. But too much steroid early is no good for COVID. If you get infection with steroid, you get it worse. So for the vaccination, okay, on steroids, consult your doctor and talk through with them. Because your doctor knows your status much better, your dosage much better, and can advise you. Okay?
Okay. What about psoriasis? I think this is some sort of
psoriasis.
Yeah,
psoriasis. Psoriasis is a skin infection, chronic. It's not a reason not to take the vaccine. Psoriasis is a skin infection. Okay, depending on what treatment you are, some of the psoriasis they do use steroids. Okay, but you are not any treatment. You got psoriasis, by all means, vaccination not an issue.
Okay. What about another question about those that suffered from different allergies?
Okay, allergy is one thing that we are a bit concerned about. Okay, like I said, if you had a history of very severe anaphylactic reaction before, then at present you should avoid it. Okay, avoid it. Okay, for those with a history of allergy, mild allergy, I take a bit of food lah, I get a bit of rashes. Okay, I go to mosquito bite lah, I more reaction than other people. Those are quite normal allergic reaction. Okay, for those very mild allergic reaction, to me personally, I think I still take the vaccine. Okay, but you reveal it to the doctor who's giving the vaccine. They'll check you first, and you remain in the center for the 30 minutes. If any reaction comes, they know how to treat you. They know how to nullify the allergic reaction. Even anaphylaxis, they can treat in a proper setting. Okay, so I get very worried when I see pictures in the US. They go to a car park and inject people. Okay, I don't think we are doing it here, I hope not. Okay, in the proper clinic setting, we got all the drugs to reverse allergic reaction, and that to me is safe. So mild allergy, do talk with the doctor who's going to see you and mention the fact that you're allergic to this or that, and the proper setting is not an issue.
Okay, thank you, Pastor. Still on the same line of questioning, what about people who recovered from dengue, low immune system, weak lungs, low oxygen, gastric and ulcers?
Okay, those who had COVID before lah.
No. Previous other.
Okay, I mean all the rest, weak lungs and all that, all the more reason you're at high risk, you should get the vaccination. Okay, because your lungs already affected. The last thing you want is a COVID infection that flares up your lung. That's the last thing you want. So for medical conditions, for all those with comorbidities, hypertension, diabetic, overweight, you should get vaccinated because your protection to me is higher, because your risk is higher. Okay, that's important.
All right, maybe one more last question on comorbidity. What about liver problems?
Liver is not an issue. By all means, liver does not affect as such. Okay, if you're a hepatitis B carrier or whatever, to me, it's not an issue. Okay, it won't affect the vaccine per se. And if anything, you are also high risk. Okay. Okay. Any other questions? See on the chat, there's some questions.
Yeah. I'm actually vetting through some because some are questions. Okay, since the government is going to implement a national vaccination policy, which basically means that there is no choice for us to choose which vaccine. All right. So there are questions whether can we go for our own choice of vaccine, number one, and can we get it outside from private hospitals and so on and so forth. I mean, it's a policy issue at this moment.
Okay, best as we know, okay, you're from medical circles, okay, so far government has not allowed the private sector to import the vaccine and to vaccinate people. So far, they have not allowed, because this vaccine is being categorized for emergency use, and there's a short supply. Okay, so limited supply. So far, they have not allowed the private hospitals to import. If they cannot import, they cannot inject. Okay, so that is the status. It may change down the road when more vaccine is available. Okay, to me, I'll just tell my class chat group. Okay, it makes sense for the government to allow the private hospital to do it. They save money, they save time. Let everybody get it done outside, and people are happier to have the vaccine of their choice. Okay. But because the vaccine is short supply, so far the government has not indicated that they are willing to let private hospital bring it in. So far, that may change. I don't know. Okay. Okay. Any questions?
Okay. There's a question on the whole area of the efficacy of the vaccine. You showed different types of vaccine at different levels. So the question is, does it mean that the higher it is better?
Okay, I mean, scientifically, these are just numbers. But I hope you remember the chart that I said phase 3 vaccine results for all the 5 major vaccines is all 100% for prevention of severe illness, hospitalization. That to me is the more important chart. Okay, so now, especially in our country, we got no choice of vaccine. Personally, whatever is offered to me, I will take. Because that will at least says that I am protected, maybe not against the initial COVID thing, but against severe disease. And that's what we need. Okay, for those you want to know, I'm hypertensive as well. I'm in treatment for the last 20-30 years. Okay, so I got one small comorbidity. Okay, so anything that will protect me because of my slightly increased risk is okay. So it may not protect me from all the infection, but let's protect me from severe and needing hospitalization. And that to me is very important. But at the end of it, we want to lower the hospitalization and severity rate, and that will help our health service to be able to help everybody. Okay?
Okay. One more question on the age of vaccination. Is there an upper age, as in, you know, some of our seniors,
18 years old.
The seniors, let's say,
seniors. There's
90s.
Okay, there's no upper limit. Okay, overseas there are so many old people in Sweden and all that. They actually the first group to get vaccinated because they are older and higher risk. Okay, the lower age 18 or some countries 16 is because the vaccine studies were done in that group. Now they're doing studies for children below that age. Until those studies come out, we are still not clear. So at present our government is scheduled, I think 16 or 18 to as old as you are. Okay, there's no upper age. Okay.
Okay.
What else?
Let me just look through some of the questions. There's actually a question not very clear. There are many deaths and adverse side effects reported in VAERS. Right, I'm not sure. VAERS.
Oh, okay. That is the vaccine reaction side effect group in the US. They got a web page for it. Okay. Again, I stress correlation and causation. So what happens is everybody who got vaccinated, any so-called side effects, they can text into that group and you'll be considered. Okay? And the government authorities want to see, is there a pattern? Is there a pattern? What happens is, in this world of infodemic, somebody gets immunized, okay, 2 weeks later he died of something. We straight away do correlation causation, which may not be the truth. Even all those who died in Sweden, the 80 years old and died, 20 people died and all that, they look at the mortality, it's about the same as normal. It's the same. But everybody here about the 80-year-old who died after vaccination. So what we are saying is correlation is not necessarily causation. And the medical authorities are very concerned. Any death because after COVID vaccination, they try to investigate and see whether there is actual correlation or not. So some of them, they don't know. They don't know. So it's open-ended. Okay. So don't always just read all the side effects. Oh yeah, so many people have side effects. You must know how many of the side effects are normal effects. Okay, as a normal run of life. That's important. That's why I shared the part about how many people expect to die in Malaysia or 65 and above. The statistics is there. We only get worried if instead of 1,000 over die, it's only 3,000, 4,000 die when it's above the normal. And all of them after vaccination. Then we got a thing on our hands to consider. Okay? So we must be very careful in reading all the statistics come, and information is so easily shared. So easily shared that it becomes infodemic. That's why I said that is more dangerous to many of us, because we read and we see the wrong things. They are not verified. And sad to say, I think we are losing the battle Because all the WHO page, CDC page, they are all very boring. They're all facts and figures. No cartoons, no drawings. Okay, so what I've done is I try to find proper illustration to be able to illustrate what the medical journal is trying to say. That's what I'm trying to do. And make it simple in layman's terms that you and I can understand. Okay, because ask you to read the Lancet, New England Journal of Medicine, it's very, very boring statistics. The information all there, but it's very boring. Okay, so some of the better sites to visit is some of the newspapers are very good. They give you graphics. A lot of my graphics is from New York Times. Okay, they got all this COVID page and they explain to you in graphic form. That's easier for you to understand. So I hope that helps lah. Okay, any other question?
Okay, Pastor, just on the age of vaccination, why are those below 16 or not excluded from the vaccination?
Okay, I think the below age is two reasons. One is that all the studies initially done were above 16. Okay, so we got result for 16 and older, but no below. Okay. Second is these are what we think the very low risk group. Okay. So when they studied the phase 1, 2, 3, they only studied 16 and above. Now I understand there are studies being done 16 and below. Same as the pregnancy. The initial first 3 phases excluded everybody who is pregnant. Okay. But what they found is a lot of them after getting the vaccine got pregnant. Okay, and so far all the pregnancy went to term except I think one abortion. And the abortion case was they didn't get the vaccine, they got a placebo. So now in the US, there is a study whether the vaccine is safe in pregnancy or not. Because they only can tell you what they study. They cannot just assume. Okay, so pregnancy itself now, they'll say, if you can, Singapore says, don't get vaccinated if you can. Okay, but so far, those who got vaccinated and became pregnant, okay, the result has been good. So if anything, it's not a major side effect.
Okay, thank you,
Anything
Pastor. Okay, I think there are a lot of questions about personal medication and so on and so forth. I don't think it's possible for Pastor to explain everything.
No, I make a general statement. If you're any medication, okay, as long as it's not allergic based, hypertension, diabetic, and all that, okay, it's safe to take the vaccine. And if you're hypertensive, diabetic, and all that, you are comorbid, higher risk, take the vaccine as a general thing. If you are not sure, talk through with your doctor. Okay, as a general rule, thyroid and all that is perfectly safe to take the vaccine.
Okay. Probably the last, the last section. The question will be more on the infodemic. I think there are still people using question about the vaccination and this pandemic at end times and
they want to wear a pastor's hat. Okay, I won't go into all that's being speculated. There's so much on the net. Okay, I think to me personally, we will see pandemics. This will not be the last. We will see more pandemics. Okay, that's only biblical. But I don't think this is the final one. Okay, this is not the final one. We'll see more and more pandemics and be prepared for it. Okay, and because the mRNA has come out so fast, any other virus after this, okay, we expect a vaccine to come on faster because we have the technology and we understand much better. That is advancement of science. If you always go back to live attenuated vaccine all the time, that takes so long to be able to develop, then everything will slow down lah. So we cannot say it takes 20 years last time. Why now 9 months? But that's advancement. Now your handphone is as powerful as a computer. You don't ask why. You cannot use because it's too powerful. We still use the handphone because development, advancement has come in. Okay, I think that's important for us to consider.
We have covered most of the important facts, the scientific facts, science-based evidence facts. I think it has been very clear. I think there is no more major question that you have not dealt with. Perhaps I just one last question to Pastor. So what would you advise everybody on this whole area of vaccination?
Okay, I mean, my whole point of this talk is to assure you that vaccination is the way to go. Not only for yourself, but for those around you. My appeal to is mainly the younger people who may be hesitant. You got older folks at home who will need to be protected. And if there's a way for you to be vaccinated and hopefully don't catch the virus, then it's another safety net for the people at home. Your parents, your grandparents, even your neighbors and all that. I think sometimes it's not only for ourselves, okay? Like I said, some people, I mean, I just got a text today from my class group, 0.04, so small lah, nothing lah, let's have the infection and get away with it. Okay, maybe 0.04 for you, but your parents and grandparents will not be 0.04. That's why I want to emphasize. Okay, so don't only consider yourself, but consider others as well. And all the theoretical risks of long-term autoimmune and all that, time will tell. But at present, it remains theoretical. Okay? And what we face is a pandemic that is taking life and taking a lot of lives. Let me emphasize that. Okay? So it's not something to be play lah. Malaysia, actually, our rate is thankfully is not as high as the US. But on the other hand, Asians are more compliant. We wear our masks and keep our distance, and we don't protest against all the things. Okay, so I'm thankful. I'm thankful to be Malaysia.
Somebody asked, for those who don't have handphone, the old people, can you advise them how to register? Thank you.
Okay, they got website for you to go and register. That's one. Failing which, you got no handphone or no website, you walk into a health clinic to register. You can register in person. Okay, the health clinics are supposed to be set up to register for vaccination as well. Okay?
Come, let's pray. Father, we want to just thank you for this afternoon session. Thank you also for Reverend Dr. Ng for his sharing. Thank you that he's able to share clearly, concisely, with facts that are also backed up. Lord, we want to just pray, thanking you also for science and for technology, Lord. Thanking you also for the scientists that have worked fast to develop and come up with vaccines to protect the global population against this pandemic. We continue to just pray that even as we have been given that opportunity to be vaccinated, Lord, that we will consider carefully that whatever fears that we might have, Lord, we continue to just pray that you will help us to seek out the right information that will be able to help us to take the right decision and actions. We want to just thank you for this time. We want to just pray that your blessings will just go with all of us. We want to just give thanks in Jesus' name.
Amen. Amen.